Hello everyone. In today's video, we will solve different kind of problems related to time value of money. In the previous video, we simply talked about the lump sum payment when there is only one payment either in the beginning and we were trying to calculate the future value, or there is one single payment at the very end like in future time and we were trying to calculate its present value. So as we discussed in the previous video, there can be three situations broadly. One can be a lump sum payment. Other situation can be annuities. We have already talked about the meaning of annuity as well as ordinary and annuity due in the previous video. So the second situation was for annuities and third was for mixed stream. The difference between annuities and mixed stream is, although annuities as well as mixed stream, they have multiple payments at different points in time, but the difference between two of them is that annuities will have equal payments at equal intervals. When these conditions are not satisfied, that is considered in the category of mixed stream cash flows. Okay, so we will try to solve some of the problems related to annuities as well as mixed stream cash flows. So we already talked about this, and this is the formula for calculating future value of an ordinary annuity. So it is like calculating the future value in a similar manner. Like we have multiple payments as we can see on this timeline right here. One is at period 1, at when T1, at T2, T3 and T4. There are 4 different payments. In the previous example, we had just one payment and we were trying to calculate its future value right here. Okay, now we have multiple payments. So the first situation right here, it says that you can calculate the future value of all these payments separately and then sum all of them together. For example, it would be the future value of these $100 where we start from T1 and end at T4. Okay, so there would be 3 time periods to get this future value. Then this future value for this $100, there would be two times compounding. Okay, for this one there would be 1 compounding and the future value is for the last $100 would stay 100 only. Okay, because it is in the same time, and we will add all of them together to get the future value of all these 4 payments. There is also a formula where this cash flow, CF1 here stands for the cash flow, which is this $100 times 1 plus R. R is the rate of interest to the exponent of N. N is the number of time periods minus 1 divided by R. This is the formula when you are not trying to use your financial calculator or Excel spreadsheet. You can use this formula. It's one and the same thing. Okay, so you will get the result from this also. Now let's solve this problem. Suppose you receive a 3-year ordinary annuity of $1,000 per year and deposit the money in a saving account at the end of each year. Now the point to be noticed here is that you are depositing the money at the end of each year. Okay, so this end means when the payments are at the end of every year, that means that is ordinary annuity. Okay, the account earns interest at a rate of 6% compounded annually. So compounding frequency is annual. We'll talk more about the compounding frequency towards the end of this video. How much will your account be worth at the end of 3-year period? So let's take the note of the major inputs here. the first input, if you remember, we have 5 functions in our financial calculator which starts with N. The first input would be N, then our interest rate, then the present value, PMT, and future value. So here, since it's a 3-year time period, our N would be 3. The interest rate, since it is like the account earns interest at a rate of 6%, so our interest rate would be 6. We do not have anything at present, no present value, so that would be 0. We have equal payments of $1,000 at the end of each year. So PMT in our financial calculator stands for payment. So these $1,000 would go towards PMT. FV stands for future value. Okay, that's what we are interested in calculating. So let me show you how do we do that on the financial calculator. So these are the inputs. N is 3, interest rate is 6%, present value is 0, payment is $1,000. We have to calculate the future value. So these are those 5 functions. Okay, we will plug all these values in this. The first one is N, 3. Okay, then interest rate is 6%, 0 is our present value, $1,000, and since it is a cash outflow, it would be negative payment, and we have to compute future value. It gives us a future value of $3,183.60. If you want to just approximate it, it can be $3,184. Okay, this is the future value. So it is basically, let me show you the timeline for these cash flows right here. 0, 1, 2, and 3. Okay, so 1, 2, and 3. There are 3 payments at the end of each year. Okay, the first year, here, second year, and third year. We are trying to calculate the future value here. So it is exactly what we did here using this financial calculator is exactly what I told you earlier. First, we will calculate the future value of these $1,000. Now, how many times this $1,000 has to be compounded? First, it would be compounded at the end of this year because you are investing it here at the end of this year. So first compounding will take place here and second compounding will take place here. So basically 2 times compounding. So N would be 2. Okay. Interest rate is still 6%. This is the present value if you want to calculate the future value. Now you would say that, oh, you were telling that this is PMT here, and now you are saying this is present value. I am saying it as present value because I am calculating the future value of only this amount. No regularity, nothing, whether it is reappearing or not. Okay, so I want to calculate the future value of only this amount. So this is the amount at this point. What would be the future value? Okay, so let's do that. N would be 2 in this situation here. Interest rate would stay the same. $1,000 is the present value. Payment would be 0. We are computing the future value. It is giving us a future value of $1,123.60. Okay. Now let us calculate the present value of this amount right here. Now everything is same. Your N would change to 1. Okay. So now N is 1. Interest rate is still 6%. $1,000 is the present value. 0 is the payment. Compute future value. This is giving us 1060.00. This value is already the value at this time, so it will stay the same, which is $1,000. If you will add 3 of them together, what do you get? $3,183.60 or $3,184. I mean, if we will approximate it. Don't you think 2 of them are exactly the same? That's what I meant when I was talking about this formula right here. Okay, so it is similar to calculating the future value of different sums at different points. Okay, and then add them all together. Okay, so sorry, yes, so this is exactly what I did in this problem right here. Okay, so either you can use $1,000 as PMT in your financial calculator and solve it in just one step, or you can calculate separately the future value of all these payments. But you always need to understand the timeline correctly. If you are investing $1,000 at the end of your first period, that means you are investing on this date. So how many times will it get compounded until the very end when you want to calculate the future value? So this amount which is being invested right here, it will compound once and just 2 times. Okay, that's how we calculate it. Okay, these are all those future values. This is for the third year, second year, and first year, and once you add all 3 of them together, you get the future value of annuity. Okay, this is the future value of that 3 years annuity. Now, till now we were talking about ordinary annuity, when the first payment is due at the end of first time period. Okay, or first year. Let's say, let me try to make it little easy for you. I will say first year, because so far we are talking about the annual things only. We are not talking about semi-annual or quarterly compounding. That's why it would be easy for you to understand if I would just say first year. Okay, so in case of ordinary annuity, the first payment is due at the end of first year, whereas in case of annuity due, the first payment is due in the beginning of the time period or first year. Now see, so first payment is due in the very beginning. So how many times will it get compounded? Once, twice, thrice, and 4 times. Second payment will get compounded once, twice, and 3 times. Third payment will get compounded 2 times, and this fourth payment will get compounded 1 time, and there is no payment after that. Like there are total 4 payments, and they will get compounded this way. Okay, so once we are doing it, basically if you see, it is kind of multiplying. Like in this situation also, one extra compounding is there. Extra compounding means multiplying that by 1 plus r or 1 plus I. In this situation also there is one extra compounding, one extra compounding, one extra compounding, and when you are taking the summation of all of them together, you can multiply all those values by 1 plus r. Okay, so if you want to, the best and the easiest way to solve the annuity due problems is calculate it normally as an ordinary annuity and multiply that by, do the compounding one more time. That means multiply the result by 1 plus I. Okay. Now, it is exactly the same problem that we just solved. The only difference with this problem is that the payments are in the beginning, at the beginning of each year. Okay. So the problem here says, suppose you receive a 3-year annuity due of $1,000 per year and deposit the money in a saving account at the beginning of each year. The account earns interest at a rate of 6% compounded annually. How much will your account be worth at the end of 3-year period? So we don't have to do anything. We will just multiply our $3,184, which was the result of ordinary annuity. We will multiply that by 1 plus 0.06. That means 1 plus R. So 1 plus 0.06 is 1.06. And if you will multiply your $3,184 by 1.06, you get $3,375. This is the result, 3,375. Because first payment is here, so it is compounded 3 times, it is compounded 2 times, it is compounded 1 time, and we are adding all of them together. So together, one extra compounding take place compared to the previous timeline. That's it. Okay. So that's why the formula is like this. This is future value annuity factor. You don't have to worry about it. You just solve it the way I told you to solve. Okay. Now it comes to getting the present value of an ordinary annuity. There is no difference at all. You are going to do the same thing. In the financial calculator in the previous problem, we had some inputs. First was N, then we had the interest rate. There was no present value. We had payment of $1,000 and we calculated the future value. Now we will have 0 as future value and we will calculate the present value. Okay. Suppose you receive a 4-year ordinary annuity of $1,000 per year and deposit the money in a saving account at the end of each year. The account earns interest at the rate of 6% compounded annually. How much is this annuity worth to you? I want to leave this problem for you to solve, not only ordinary annuity, but the present value of annuity due also. It is exactly the same. Once you get the present value of ordinary annuity, multiply that result by 1 plus R and you will get the present value of annuity due. So I want you to try these problems on your own, solve on your own, and then we will, if you have any problems, any questions, that can be I can take care of those problems either via email, if you want to shoot me an email, or in the live class session, whenever you feel comfortable, wherever you feel comfortable, if you find any problem. Although I am sure there won't be any problem. This is all about those 5 functions of financial calculator. You just need to identify which value represents what. So we are doing the opposite of all that. There we had these values and we were trying to find the future value. Now we are trying to find its present value. So doesn't make any difference. This would be payment, this would be I, this would be N, future value FV would be 0, and you will compute present value, and that will give you the answer 4212. And this is the answer for annuity, ordinary annuity. If you want to get it for annuity due, multiply 4212 by 1.06. Okay. So now you can do all these problems on your own. Now let's talk about mixed stream. So cash flows are unequal with no specific pattern in terms of timings. Okay. In annuity we had specific pattern, so we could use those 5 functions. But for mixed stream, we cannot use those 5 functions in the calculator. It would be some different functions that we'll be using. Now look, this is the problem to get the future value of a mixed stream. BPC Incorporation expects to receive the following mixed stream of cash flows over the next 6 years from one of its new projects. If BPC expects to earn 9% on its investments, how much will it accumulate after 6 years if it immediately invests these cash flows when they are received? Okay, so getting the future value here is exactly the same, that for every payment you can get the future value. For this one right here, for this one, for this one, for this one, this one, and this one. And always remember that if you are trying to do this, you should always have a timeline in front of you. Okay, so let me show you these things on the timeline first, so that it's easy for you to comprehend this problem, to see what we are doing. Okay, let me just get you a timeline. So T0, 1, 2, 3, 4, 5, and 6. Okay, we are interested in calculating the future value. At T0, it is 0. At 1, it is 11,500. At 2, it is $12,000. Then $14,600, $13,000, $16,000, and $18,000. So exactly the same way as we solved the problem of annuity, if we are taking one by one, we are taking all the cash flows one by one. So what will you do? You will calculate the future value of 11,500. The interest rate in the problem is 9%. Okay, how many times the compounding is taking place here? 1, 2, 3, 4, and 5. So you will get the future value of 11,500 let's plug the values one by one. N, 5 years, interest rate 9%. Okay, present value is this value, 11,500. Zero would be payment, because no reoccurring things are there, because I'm trying to just get the future value of this number. That's it. Right now, just forget about all these cash flows, because we are considering each cash flow as a separate thing. Okay, so since I'm trying to calculate the future value of this number right here, I should forget about any other cash flows. Okay, so payment would be 0, and then compute future value. So it gives us a future value of $694.17. Okay, now let's talk about this. Again, the future value here would be so n is now, what is n in this problem? How many times compounding is taking place starting from here? 1, 2, 3 and 4. Okay, so the compounding is taking place 4 times. 4 is the value of n. 9% is the interest rate. Present value is $12,000. 0 is payment. Compute future value. It gives us a value of 16,938.97. Let's go for the next one. 1, 2, 3. So compounding is 3 times. So n is 3 here. In first one, n equals 5. In the second one, n equals 4. Interest rate is 9% throughout. So $3 is the value of n. 9% interest rate. Present value is $14,600. 0 is the payment. Compute future value, which is 18,907.42. Okay, so next it would be, n would be 2 here. $15,000 is the present value. 9% interest rate, 2 years. 0 is the payment. Compute future value. It gives us 15,445.30. Next one. $16,000 is the present value. 0 is payment. 9% is interest rate. 1 year is n. Compute future value. It gives us 17,440.00. And the last one, the future value, will remain $18,000 as it is. Okay, that's how we calculated the future value of all of them, right? So then we can add all of them to get the future value of these stream of cash flows. Okay. Let's add all of them. 17,694 plus 16,939 plus 18,907 plus 15,445 plus 17,440 plus 18,000. It gives us the future value of 104.104425. So this is the approximate future value, 104,425. Okay, so this is one way to solve this problem. The other way can be, we can directly use the financial calculator and then we can solve it. So the keys that we can, the functions of financial calculator that we can use for such kind of problem is these CFNPV function. Two of these functions will be used and they will help us to solve this problem really quickly. But always remember NPV, what NPV stands for. NPV means net present value. There is no way you can calculate the future value of cash flows directly from the financial calculator. You cannot do that. Directly, it's not possible for you to do. Okay? The only way you can do that is, first, for all these cash flows right here, for all these cash flows, you will enter all these cash flows and you will get the net present value of all those cash flows. So net present value means that would give us the value at this point, the total present value of all those cash flows at this point. But since we need the future value, whatever present value we got here, we can always go back and get the future value of this one lump sum payment. Let me show you how we will do it. So we had some cash flows entered over there already. So first hit the CF once. If you have anything in here, hit second and clear work. Okay, so that will clear all the existing cash flows or anything that we already have, right? So let's start entering the cash flows. Now see, this time is 0, so the cash flow at this time would be CF0. Cash flow at this time would be CF1, CF2, CF3, CF4, CF5 and CF6. Okay, so these are the cash flows. So first, CF0, this is 0 already. We know from here that our first cash flow is 0. Okay, that is I'm not sure. Yeah, that's not, yeah, this way you will be able to see. So the cash flows, this is CF0 already. As soon as you will press this button, it will show us this value. So first cash flow has to be 0. So on the very top right here, you can see enter, and these are two of those arrow keys, down arrow keys and up arrow key. So once this is the cash flow, enter this and down arrow key. Now it is asking for the next cash flow, first year's cash flow. And the first period's cash flows are $11,500. Enter down arrow key. Now this is asking for F. F here stands for frequency. So how many times this 11,500 is being repeated here? Like the next values. That is not the same. Since it is not same, the frequency of 11,500 is just 1. Enter this frequency, down arrow key. It is asking for second year's cash flows, which are $12,000 here. Enter, down arrow key. The frequency for second year's cash flow is also 1. Next one is 14,600. Enter, down arrow key. Frequency is 1, so enter, down arrow key. Fourth year's cash flows are $13,000. Enter, down, enter, down. Okay. Fifth year's cash flows $16,000. Sixth year's cash flow $18,000. The frequency again is 1. Once you reach at this stage, press this button NPV. Once you press NPV, it is asking for I. I is the interest rate, which is 9% in this problem right here. So 9, enter, down arrow key. Now it is showing NPV equals 0. Can you see the symbol that it says here? Compute. That means you have to press the button CPT compute. So it gives us a value of 62,265.7393. So this is the future value, remember. But what the financial calculator has given us is the present value, which is 62,265.7393. So this is basically the value of all these cash flows at this point right here. So this is the value at this point, but we are not interested in calculating the present value. We are interested in getting the future value, which has to be the value there. So basically now we have just one single value. This is the present value. We know the interest rate. We know our time period n, which is 6, because compounding will start taking place from here and there will be 6 time periods up to this point. So we can calculate the future value of this single cash flow, and it would be similar to what we did in the previous video, one single amount. So let's do that. 62,265.733. This is the present value. Okay, n is 6, interest rate was 9%, 0 is the payment, compute future value. This is how you will get the future value of those cash flows. $104,425.87, and it is the same thing right here. Okay, and the difference, little bit of the slight difference, is because of the approximation that I did here. Okay, so that's how you calculate the future value of mixed stream. I explained you 2 different ways. One, you can choose to do separately for every single payment, but definitely you need to know how this timeline works and then add all of them together to get this value. Or you can use the cash flow function given in your financial calculator. Once you use this cash flow function, you will get NPV. Always remember, this cash flow function will give you the present value. Once you have the present value, you need to calculate the future value. Okay, that's what you would do. So now let's talk about that's what we just did. Now future value of mixed stream when the cash flows are repeated. These repeated cash flows, the difference will be only while we will be entering those cash flows. So frequency, you remember frequency? For CF0 it did not ask for frequency. For CF1 it asked for the frequency, and the frequency was 1. So we just simply pushed the button enter, and then we pushed the button which says the down arrow key. Okay. Now next cash flow would be $12,000, and the frequency for this $12,000 here is 2. So you will enter 2 as the frequency for that cash flow. Okay, and then you will push enter and then down arrow key. Then next cash flow, it will say CF3. What you will see on the screen of your calculator is CF3. So for that one, although you would argue that third cash flow is this one, But by entering the frequency, we have already taken care of that part. Okay, so you don't have to be worried about it. Your calculator is smart enough to take care of it. So next cash flow would be $16,000 and the frequency for that cash flow is 3. Okay, and you are done with entering all of the items. Once you will do that, press NPV. It will ask for I, which is 9% again in this problem. And then it will ask you to press the compute button to give you NPV. This calculator itself took care of that. It is repeated 2 times, that means 2 different years are there. This is repeated 3 times, that means 3 different years are there. So number of years, it will make sure that number of years are considered as 6. So you don't have to worry about it. Even if it shows you that is CF3, but the cash flows that have been entered are up to this point. Okay. Once you do that, you will get your net present value. Once you get your net present value, you will have to get the future value of those cash flows. Okay. So solve this and just let me know if you face any problems with this. Okay. I mean, these questions that I'm giving you in the middle, they are just for the purpose of like practice. It would give you some practice. So you should definitely solve these problems. Present value of mixed stream. I don't think I have to tell you the present value now, because what we already did was when we were calculating NPV, that itself was giving us the present value. So you can solve it on your own. While calculating the future value, we did one extra step. Here, since you are calculating the present value, you will stop at NPV. Once you get the NPV, that is the answer for your problem. You don't have to calculate the future value further. Now, the other pattern that we observe is perpetuities. Perpetuities means forever you will keep getting the same amount forever. You don't know how long would it be, for an indefinite time period. For example, $1,000 you are going to get indefinitely. If that is the case, 1,000 divided by your interest rate, you can say it R or I, whatever you want to say it. And that would give you the present value of perpetuities. Okay. This is also one of the problems for that mixed stream that we just solved. You can try this one as well on your own. Here we are calculating the present value of these different cash flows. Remember, these are positive cash flow. This is a negative cash flow. So when you are entering that cash flow, you can enter that as a negative cash flow too. You can do that. Okay. Now we will talk about the difference between nominal interest rate and effective interest rate. When we'll talk about nominal and effective interest rate, there is one thing which plays very important role, that is compounding frequency. Let me tell you, if compounding frequency is annual, nominal interest rate and effective interest rate, they are exactly the same. Okay? But if compounding frequency is different, then they will make a difference. Then there would be a difference. So nominal interest rate is something which is the contractual interest rate. Whenever you see, like whenever I'm saying that, okay, it earns an interest of 9%. This 9% which is mentioned in the contract or which is stated there, that is your nominal interest rate. Means in the namesake, means whatever you see. Effectively, the actual amount of interest that you earn can be different from what you could have earned at 9%. And that difference will be just because of compounding frequency. Now let me show you how. Okay, so let me give you a very simple example. Let's say you have $100. Okay, you invest your $100 today, and your friend also has $100. Okay, both of you have $100. Both of you invest your $100 today. You are earning, both of you are earning 10% interest rate. Okay, so R or I, whatever you call it, that is 10% in both the cases. But for you, the compounding is annual. So compounding frequency. Annual for you, for your friend, it is semi-annual. Okay. So what happens after 1 year? Today you have $100. After 1 year, you will earn interest at 10%. So 1.1 plus 0.10 to the power 1. This is how we do it, if you remember. Okay. So it would be $110 after 1 year. When the compounding frequency is semi-annual, what happens? Every 6 months you will keep getting your interest. So 10% is annual interest rate. So with after 6 months, how much are you going to earn? You will have 100 times 1.05, because your rate would be half, because you are investing your money just for 6 months. So it is 100 times 1.05. So after 6 months, you have $105 with you. Now you will again invest your $105 for another you are investing this again for another 6 months, because you want to compare after 1 year what is your position versus what is your friend's position. Okay, so whatever you earned, you again invested that amount at the same rate. Okay, so 105 times 1.05. That means 110.25. So you had $110, your friend had $110.25, because compounding means what? Compounding means earning interest on interest. More frequently you are compounding, whatever interest you earned during that time period, that will also start earning interest. So this 25 cents difference is just because this extra $5 that you earned as interest during this time period was also invested at 5%. So that's where this 25 cents came from. So basically your interest amount here is $10, total amount minus your principal that you invested. So your earning or your interest is $10 in this situation, whereas it is $10.25 in this situation. Nominal rate, the rate which was on the contract, that is exactly same on both of them. So this is called the nominal rate. Whereas just because of compounding frequency, effectively your friend could earn more than what you could earn. So this effectively how much actually you are able to earn, that gives effective interest rate. More frequent this compounding frequency is, higher would be your effective interest rate. If in both the cases compounding frequency is annual, for annual compounding frequency, nominal interest rate as well as effective interest rate are same. So how much actually you earned. Whereas if the compounding frequency is somewhat different than annual, effective interest rate would always be greater than your nominal interest rate. Okay. So this is the annual rate of interest actually paid or earned. This is also called true interest rate. So whatever I just did here, compounding frequency, since I was doing for 1 year, so I showed you how the interest is reinvested to earn more. So for the same future value formula, if you remember, our formula was present value times 1 plus r to the power n. Okay, n was the number of periods. Now this m, we will have to adjust this r and n here in the formula to take care of the compounding frequency. Okay, so m here is the compounding frequency. For example, in case of semi-annual, how many semi-annual time periods are there in 1 year? 2. So the compounding is taking place 2 times in a year because it is semi-annual compounding. So the compounding will take place 2 times in a year. That's why m becomes 2. And if you remember, when I was solving the problem, instead of 10%, I used the rate as 5%. So 10 divided by 2. The 5% interest rate we should use. And number of time periods. Now, how many times compounding will take place? N means how many times the compounding is taking place. In 1 year, compounding is taking place 2 times. If there are 5 years, 10 times compounding will take place. So compounding frequency times number of years. Okay. Always keep it in mind. Rate and time periods, number of periods and the rates, they should always be consistent. If the compounding frequency is 2 and we are taking care of that while calculating the number of time periods, the rate has to be divided by that, because shorter the time period, the interest rate, like more frequently you are compounding, the interest rate would be based on that time, one time period only. So that's why if your rate is divided and time is being multiplied by the compounding frequency. Both the things should go hand in hand. That would be wrong if within 6 months also you are earning 10%. No, you cannot earn 10% in 6 months. If your earning is for 6 months, 10% is the annual rate. Okay, so in 6 months you will be able to earn half of it, not the full amount. Got it? So that's why R has to be adjusted and this also has to be adjusted. Okay, this compounding frequency can be quarterly. If it is quarterly, that means there are 4 times compounding is taking place in a year. And if it is 4, then rate would be 10 divided by 4, which is like 2.5%. And number of periods, let's say 4 years time period is there, and every year 4 times compounding is taking place. So the total number of times the compounding is taking place in 4 years is 4 times 4, which is 16. Okay, that's how we do that. We adjust it. So when you are plugging the numbers in your financial calculator, you will already adjust your R by dividing it by M and N by multiplying it with N. So if you have to solve that kind of a problem, your R would be 2.5 and M would be 16. Okay. Sorry, N would be 16. N means number of times the compounding is taking place. That's it. Okay. And there is another situation where continuous compounding is being done, like every second, every fraction of a second the interest is being compounded. Okay, so to take care of that, this is the formula that we use. Okay, present value times E to the power of R times N. R is the interest rate, N is the number of time periods, number of years here in this situation, because you know there won't be any M because m is indefinite, right? Because indefinitely compounding is taking place. So there won't be any m, which is, and that is an indefinite number. So that's how we will solve that. This is the formula that we'll use for that. Now look, effect of compounding periods on present and future value. What would happen to the future value? If you remember from the problem, when compounding is taking place 2 times, the future value was greater, right? For you it was $110. After 1 year the future value was $110, whereas for your friend it was 110.25. okay, because the compounding was more frequent for your friend. Your friend was getting a chance to earn interest on interest as well. So more frequent the compounding is, higher would be the future value. Okay, if it is yearly, future value is this. If it is semi-annual, future value would be, you can try these things by solving this problem. 1000 would be your present value, 10 would be your R, m would depend on if it is yearly, m is 1, if it is semi-annual, m is 2, if it is quarter, m is 4, if it is monthly, m would be 12, if it is daily, m would be 365. It is continuous compounding, you will use this formula right here. Okay, by doing that you can get all these values and see more frequently compounding is, higher would be the future value. Opposite would be the case if it is the case of present value. In case of present value, lower would be the present value, more frequent the compounding is. It would be completely opposite, because if you remember, in present value you are dividing things. You can try solving all these things and you will get the same numbers, and you can then see the logic how it is taking place. Okay, if you have to calculate the effective rate, this is the formula for effective rate. We know the nominal rate, which was 10% in our example. So effective rate would be 1 plus nominal rate, which was 10%, m, which is the compounding frequency, that means 2. So 10 divided by 2 would be 5 to the power of 2 minus 1, and that's how you will get it. Okay, if your nominal rate is 12%, your effective rate is 12.55%, and if it is being compounded quarterly. Okay, so you can do the same thing using the financial calculator. I can show you how. In the financial calculator, to solve it, I'll tell you what function that you use. Do you see here on the number 2, right above the number 2, ICONV? CONV means conversion. I is for interest. So interest rate conversion. If you know effective rate, you can get the nominal rate. If you know your first, I just cleared it. If you know nominal rate, you can get effective rate. If you know effective rate, you can get nominal rate, whatever the case is. Okay, so press second, go for it. Okay, how did I clear this? Once I reached to this stage, I saw this nominal here. Again, I will hit this second and this button right here, clear work. Once I do that, I can simply clear that if something is in the background. So nominal rate, as in this example, was 12%. Okay, enter. If you go for down arrow key, it shows effective. You don't have to go for it. You are trying to see what your compounding frequency. CY stands for the compounding frequency, how many times the compounding will take place. In our problem, it will take place 4 times. Enter, down. This is nominal, you don't have to go there. Down. When you reach there, just press compound. compute. It will give you 12.55%. Okay, so if you know the nominal rate, this is how you can get the effective rate using your financial calculator. Okay, this is what they got. This is what we get using our financial calculator as well. So net present value rule, we will talk about this rule when we'll do those capital budgeting problems. So present value of future cash flows minus initial outlay. Okay, that's all for it, and please feel free to send me your questions if you have any. I would be happy to help you with that. Okay, so have a great day, and after this I will record another video where I will completely talk about Excel, how to solve all these problems using Excel spreadsheets. I kept myself restricted to financial calculator and some of the formulas here, but the same thing I will show you how to use how to solve using Excel spreadsheet. Okay.